All right, so let's go to the new vocab. A function f of x equals the absolute value of x is known as the absolute value function. F of x equals the absolute value of x is known as the absolute value function. The highest or lowest point on a graph of an absolute value function is referred to as the vertex. This point is referred to as the vertex. Absolute value functions are unique in that you can take their graph and fold it in half at the vertex, and all of the points on the right side and all of the points on the left side will always match. So you can take an absolute value graph, fold it in half at the vertex, and all of the points on the right side will match all of the points on the left side. So if we go up to right one, you're going to go up to left one. So all points go up and over the same. That property you'll hear me call AOS, but I'm too lazy to write out axis of symmetry. I will say AOS. So it'll be symmetric about that line. An absolute value graph can only have one axis of symmetry. An absolute value function can be written as a piecewise function. We're going to talk about piecewise functions next week, but all absolute value graphs can be written as piecewise. That's where you have a negative slope, a zero, and a positive slope. This is what makes the graph symmetric. There are 5 characteristics that are key to all absolute value graphs. The first is that the domain of all absolute values are always all reals. The domain of all absolute values are always all reals. The range is y greater than or equal to 0. The range is y greater than or equal to 0. The vertex for today and your homework tonight will always be 0, 0. The vertex for today and tonight will always be 0, 0. The AOS for today and tonight will always be x equals 0. The slope to the right of the absolute value graph is 1, 1. The slope to the right is 1, 1. And then it's important to know that the slope to the left, or the opposite, is negative 1. So up at the top, I gave you a graph to put that parent function. So we're going to apply these characteristics to that parent function. The graph goes through the point 0, 0. That is our vertex. The AOS is represented by that dashed green line. That is the graph line that cuts it in half. And again, my slope to the right is 1. So you have all of your points that go up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1. Because the graph is symmetric, if it goes up 1, right 1, then to the left it goes up 1, left 1. So whatever you do to the right, the left is the opposite. So if you were to create a table Your vertex is in the middle. What happens to the left or at -1 happens to the right at +1, which in this case is 1. If it's -2 on the left, then it's +2 on the right, and they're both at +2. Similarly, you would have 3, 3, -3, 3. As we go into other graphs, we're going to have transformations. So y equals -a, absolute value of x minus h plus k is known as the vertex form of an absolute value, because each part of that form changes the graph. The negative is what we call reflection. The negative will reflect the graph across the x-axis. The a value is going to make my graph narrow or wide, so it's going to stretch it or compress it. The h value is going to move my graph left or right, so those are known as horizontal translations. And the k value is going to move my graph up or down. For today, we are only going to focus on A and the reflection. So for today, we're only going to focus on the A and the reflection. We're going to talk about H and K tomorrow and the next day and the next day. So if the A value on the graph is positive, the graph will open up. If the A value on the graph is negative, then the graph will open down. So if the A value is positive, it opens up. If the A value is negative, it opens down. The A value represents or acts like a slope. If the A value is bigger than the number 1, then my graph is going to be narrow or stretched. If the A value is between 0 and 1, then my graph is compressed. This will make it appear wider. So if we were to graph the function y equals negative 1/2 x, it's important to know where the vertex is and describe the a value. So in this case, in the case of all our homeworks today, all vertexes are at 0, 0, which means all AOS's are at x equals 0. So all our vertexes and all our axis of symmetries are going to be at 0, 0, and x equals 0. The a value in this case has two things happening. The first thing happening is that it is negative. A negative a value is going to be a reflection. So what that means is that instead of opening up, all my points will open down. And then the 1/2 is going to be my slope. And it's going to represent the compression. So this graph is compressed. And then its acting slope is kind of like negative 1/2. So what that means is from my vertex at 0, 0, all of my points are going to go down 1 and to the right 2. But remember, if I go down 1 and right 2, I also have to go down 1 and up 2, because my graph is symmetric. So from that next point, if I go down 1 and right 2, then again I go down 1 and left 2. For absolute values, you must have 5 points. Your vertex, 2 points to the right, 2 points to the left. Connect it, and you have an upside down V. If you need a table of values, then for today and today only, you'll plug in negative, you can plug in anything to the left or anything to the right. If you did negative 2, negative 1, 0, 1, 2, you would take those points, you could plug them into the original, and you would get negative 1, negative 1/2, 0, negative 1/2, negative 1. So you get points that work, but you're going to get like kind of gross points. Because you'd have to plot that at like the half point of negative 1 and 1. Where if you just use your slope that you know how to use and go symmetric, you don't need that table aspect. Okay. Graph the following functions, identify the vertex, and describe the effect of A. So again, my A value is 4. An A value of 4 is kind of like a slope of 4. That's going to stretch my graph, which means it's going to be narrow. All graphs today have vertexes at 0, 0. So you'll start at 0, 0. Go up 4, right 1, up 4, right 1. And remember that whatever it does to the right, it does to the left. So since the graph is symmetric through this line here, if it's at 1, 4, then it's also at negative 1, 4. If it's at 2, 8, it's at negative 2, 8. Connect your 5 points, and there's your graph. Is everybody okay so far? So I said it's like tricky, but not tricky. It's just detail oriented. Okay? So identify the vertex. The vertex for today is always 0, 0. That will always be your starting point. From that vertex, you're going to apply the A value So the A value in this case is 1/4. So my quote unquote slope is 1/4. So you're going to go up 1 over 4, up 1 over 4. But you only do that to the right of the vertex. So to the left of the vertex, it's the opposite. We don't want a line, we want the V. So you're going to go up 1, left 4, up 1, left 4. Is this graph going to be wider or narrower than its parent function? Is 1/4 greater than 1 or less than 1? So if it is less than, the graph is compressed. In case you wanted to know, here's this red graph would represent the parent function in a way. So you can see how it's below or wider than that parent function. Okay, the vertex for today is 0, 0. The slope is the A value. So my slope is 3 over 2. So from your vertex, you're going to go up 3 over 2, up 3 over 2. Opposite direction, up 3, left 2, up 3, left 2. Is 3 halves greater than 1 or less than 1? So is my graph going to be compressed or stretched? Stretched. Because 3 halves is 1.5. 1.5 is greater than 1. So this graph is stretched. So for your homework, you need to identify vertex, which is always 0, 0. You need to tell me what the A value is and what it represents. And then if there's a negative, then you need to put reflection. So if it's reflected, stretched, or compressed, and then give me 5 points on the graph. 2 to the right, 2 to the left, and 0, 0. Correct.